So now, let's draw a set of axes, but let's draw it a bit different to the way we normally do it. Here's how you normally do it. See this? That's what a set of axes normally looks like, right? But see all these numbers down here? All this area down here?
It's invisible.
It's, they're all negative numbers, right? Like -1, 2, 3, 4, 5, and we're never going to use them, okay? It's irrelevant for this particular graph. So I'd like you to draw a set of axes, but this time, I just want you to draw the top part. By the way, draw it pretty tall. Draw it pretty tall. You'll see why in a second.
The whole page or like?
Actually, you could do the whole page. You could do the whole page. You could use it. If you're going to use the whole page, I'm going to use the whole height. Okay, now you guys have a tremendous advantage, which is that you have for the most part, you have grids there, okay? Even if you don't have grids, you've got lines, which I don't have, so you can measure some things here, okay? So here's what we're going to do.
That's still Y? That's still Y axes.
Yes, they are still the same axes, Y and X.
You just cut the bottom out.
That's right, I'm just not showing the bottom, because I'm never going to have something down here. Alright, now let's try to plot this thing. Okay? Now I'm just going to need a little bit more space over here.
Yes, sir.
Yep.
What if you did y equals -2 paragraphs?
Okay. If I had this graph instead, right? Think about what happened when we did this and then you compared it to this. Then think about this
It's just the same.
and then you compared it to this.
Reflected by.
There was a reflection, right? So if we can get a picture of this, if you want to know what this looks like, just take that and turn it over.
So it would just be all negative then?
That's right. Instead of all positive, everything will be negative. Let's give this a go though, okay? You've punched in some numbers, these numbers, 6 numbers, okay? So let's plot these, okay? Let's make the highest point on your graph, the highest point, let's label that as 8. Okay? So we all have a reasonably consistent thing, because that's as far as we need to go, okay? Now that's at x equals 1, 2, 3. Okay, so however wide your thing is, you can go 1 and then 2 and then 3. Okay, so there's 3. So now 3, 8. That's a point that's on our graph. Okay, so 3, 8. Something like that. Okay. Now as we go backwards, right? The next one is going to be 2, 4. Right, so here is 2. Where will 4 be? Remember we were halving, right? It'll be exactly halfway between 8 and 0. Now, you've all got different size graphs, and that's okay. Just get your ruler out and measure the line from 0 to 8. Maybe yours is, say, 10 centimeters, right? So that means where would you position 4? 5 centimeters up, right? Or whatever for however high your graph is. Mine looks like it'll be somewhere about there. Okay, so 4 and now, okay, and you can start to see what's going on here, right? 1, 2, half again. Okay, now when we get to this value, right, this is on the y-axis, right? 0, 1. Again, that'll be halfway. Okay, because that's where it hits the y-axis. Remember, that's a special point. We call it the y. Starts with an I? Intercept, very good. Okay, y-intercept. Okay, and you can keep on filling in, right? You've got a half, you've got a quarter. They're just going to be, you know, half that distance, and you have a half. Here. And if you halve it again, you get a quarter. And even though I haven't worked out, well, I haven't written down what the next one will be, it's going to be half again, right? Something like this. You can see now why it was so important to have your graph really tall. Mine is like, oh, how big's a book? Let's see. Mine is at least 1, 2, 2.5. Like, it's so much taller than yours. And down here you can still see they're all very close together. Yeah.
Got on the board, like whatever.
Yeah.
And then eventually hit the line.
Okay, so great question. Hold on, let me just repeat it and see if I understand it right, just to make sure everyone's on the same page. Nathan's asking, well, if I keep going, if I draw this further, and then plot more lines on, won't I eventually hit
No.
the x-axis?
No.
Okay, now I guess the question is, will the number hit or will my whiteboard marker hit? Now, if it's the whiteboard marker, well, the whiteboard marker, it has thickness, right? So eventually, just like with the cake, okay, you cut and eventually, where'd my cake go? It's just a mess, right? But if I think about just the numbers, right?
Yeah.
Like you said, 1 over 512, right? Or the, let's see, the biggest power of 2 off the top of my head that I know is 65,536, okay? That's a really, really small number, but it's not 0. And no matter how far you go, you will never get there, okay? So now, can we try to join this thing up? Won't be easy, right? Because it's meant to be curved, but can we connect it all up?
Yes.
Give it a go. Let's try it. Do it with pencil. Please do it with pencil, because it's not easy to do, especially this is the first time we've drawn such a graph. Connect the dots, but don't do them as straight lines, because as you can see, if you sort of step back, you can see there's a curvature to it, right?
I think I've got this just natural skill. No, it's just
You might get lucky. Okay. How does yours look? Mine's okay. I could have done it better. Yeah, it's not easy, is it? Okay, particularly like when you try to join these and you're like, oh, I missed, or it's not easy. Couple of quick questions, right? Or are you asking a question? Or are you stretching?
Asking a question.
Yeah.
So, the line will just keep getting flatter and flatter, but it will never be completely flat.
That's exactly right. Okay, so let's keep going on that. When you say it keeps going and going and going, just like we said, look, these values you could halve forever. That means this keeps going. There should really be an arrow there. It doesn't stop. It keeps going, right? And in the same way, you can keep on doubling forever. There's no upper limit. There's no ceiling. It just goes on, however far you want to draw. Okay. So you got arrows on the ends. Now, remember how we said, guess what? And this is what we just discussed. No matter how many times you halve, you'll never get to 0, right? So that means that there's always this little gap. It's approaching 0, this red line, but it never gets there. So we indicate that in a special way on our graph. I'll show you how. Right? Along the x-axis, if you can, in another color, I want you to draw a dotted line. It looks like this.
very good dotted line.
I've drawn a lot of dotted lines in my life. Okay. Now, this dotted line, just like when we started today, we said, oh look, linear graphs. We drew this one and that one and that one and that one. Okay. So linear graphs, like that dotted line we just drew, they all have equations, right? What would you guess the equation of that dotted line to be? It's horizontal. So is it an x equals or a y equals?
X equals.
Why?
It's actually a y equals. I know it's on the x-axis, but it's a y equals because all of the y values are the same. Now, what are all the y values?
1.
How high is it?
0.
It's going through the origin. It's y equals 0. Okay. So y equals 0 is a line that this graph is approaching and approaching and approaching forever and ever and ever, but it never gets there. Okay? It never turns away, but it never actually hits it. Okay? And that's a super special idea. It's so super special. When super special things turn up, you give them names, right? So this one is called, it's a bit weird to spell. It is called an asymptote. It's an asymptote. Okay? Yeah, you might have heard the word. What we say is, this graph has an asymptote. That asymptote is y equals 0. Or we say it is asymptotic down here. That's the adjective.
It sounds deadly.
It's a pretty fancy looking word, okay? So, it's getting there, getting there,
So
getting
what's the
there,
actual definition?
never arrives. Sorry,
What's
say
the actual definition of asymptote?
of an asymptote, okay? It's a line that a graph approaches, but never actually reaches, okay? And there's all different kinds of asymptotes. You can have, this one's horizontal, you can have vertical ones, you can have ones that are often an angle that are called oblique, and there are all kinds of different things. So long as you're getting closer, but never arriving, that's right. That's an asymptote, okay? Definition of frustration. Are we there yet? Are we there yet? Are we there yet? The answer is no, never. If it's an asymptote anyway. Okay.